Welcome to Tech Product Literacy. I'm going to start this lesson by talking about computer hardware. So first I want you to think, what comes to mind when you think of a computer? Many of you may think of a desktop, such as a Windows machine where you have some monitors plugged in beside it, and then you have your peripherals like a keyboard and mouse plugged into it. Or you may even think of what we call an all-in-one computer, like an iMac that has the computer built into the same case as the display. But did you think about your smartphone or your gaming console or even your Wi-Fi router? Or did you even consider maybe that smart toaster that lets you make toast using a mobile app? These are all forms of computers. Simply put, a computer is a digital device that takes input, does processing on that input to serve up output over and over again. So the CPU, or central processing unit, is what we consider the brain of a computer. This is also called a microprocessor. It's responsible for taking in the inputs or instructions, organizing them, and executing them to give us our desired outputs. So if I have a word processor open and I type the letter A, the expected output is that I will see the letter A appear on my screen. That's the process of the CPU, taking that signal sent when I hit the letter A, converting it into a format that it interprets, and then spitting out the letter A on the screen in the form of graphics. So in a typical machine, processing really happens at multiple locations, but most of it is happening at the CPU and the GPU, or graphical processing unit. Now, what people don't realize is that modern CPUs are really a combination of several processors on a single chip, and each of these is called a core. So, all things equal, a two-core or dual-core processor can be twice as efficient as a single-core processor, being able to handle twice the work at any given moment. It's not uncommon now to see not only desktop and laptop computers, but even smartphones with 4, 6, and 8 cores. So more cores means more operations at once, which allows for more multitasking. The other factor we have to consider is this one I have in the middle here, and this is how we measure how many instructions are completed per second. This is called clock speed. So if you've taken a physics class, you may remember the measure of hertz when you're talking about waves. Well, in computing, hertz represents one instruction cycle, one operation. We measure modern CPU speeds on the order of gigahertz. That's 1 billion operations. So for some perspective, my 2018 kind of mid-tier Intel Core i3 processor had 4 cores, and I think it clocked around 2.4 gigahertz, 2.4 billion instructions. That allowed me to have a fair amount of Chrome tabs open and use Word and Excel. But if I wanted to play one of the latest first-person shooters, I was going to have a problem. And that's where I'm about to talk about graphics. So, what is a graphics processing unit? Well, this is a special piece of hardware that's designed just to handle intense graphical operations. So your computer by default already has the ability to paint graphics on the screen. That is to show you your desktop with your pretty wallpapers and all your icons and your apps and your menus. So you're not just looking at green text on a black screen, because that's what computing used to be. And this is what we call integrated graphics. It's bundled with the CPU. It's economic, very low on power consumption, and it doesn't require the extra space of a dedicated graphics card. Now, a dedicated GPU or graphics card is going to allow you to do things like work with 3D modeling software, play video games that incorporate more 3D elements, more stunning visual elements. Like for some reason, Minecraft always comes to mind when I talk about games. I think of those mods with the beautiful lighting that looks ultra realistic. That needs a lot of graphical processing to load those textures and that realistic lighting. So to give you an idea of what an external graphics card looks like, here is the kind of one of the top of the line, most expensive graphics cards on the market right now. And you can see it's a pretty chunky device. It's really like a computer within a computer. And I've listed the name of my graphics card down here in my computer. I'll show you what that looks like. Well, somewhere in here. So there's my graphics card, and it actually consumes 20 watts. So 20 watts just for my 3 monitors. And then when I'm gaming, my computer consumes as much as 120 to 131 watts. And all that extra wattage is just that GPU, that graphics processing unit. So there is a balance, especially when you're looking for laptops. If you need more oomph, if you need to be able to do video editing, really high definition rendering, and gaming, then you have to consider you want to balance the power consumption, because with a laptop, battery is always a concern. So where is my stuff? Now we're going to talk about RAM, or random access memory. This is also what we call volatile storage, meaning it's not permanent. So when you see the term memory when you're shopping for laptops or smartphones, computers, this is what they're talking about. They're talking about random access memory. So random access memory, I like to think of it as working memory. So let me give you an example. When I'm writing an essay, what's in my working memory? Well, I'm thinking about my rough outline. I might have a thesis, and in my head I have these parts of the essay that I'm going through. Main topic number 1, number 2, number 3, discussion, conclusion. And I may be also thinking about other things, like I want to talk about sources X and Y in part 1 and so on. But when I take a break, I close the lid of my laptop, I walk away, I go get some lunch, I go for a walk or a run. Chances are my working memory has moved on to other things. It's no longer thinking about the flow of my essay. It's no longer thinking about all those sources, because I've had to dispose of that information to load other information into my working memory that fits the current tasks. Well, this is much the same way that RAM works. So on your permanent storage, this is where Windows lives, or Mac OS. This is why you don't have to reinstall Windows or Mac OS every time you turn on your computer. But when you turn on your computer and it goes through the process of starting up, it actually takes the contents of Windows or Mac OS or Android or iOS, and it loads that operating system into RAM. And that's so that it can operate quicker, because permanent memory is very slow compared to RAM. So by the time we've logged into our computer on Windows 11, we may already be using 6 gigabytes of our RAM just to keep Windows 11 running, just to make it happy. This is going to be less on Mac OS, but the trend generally is more RAM at idle that means what the operating system uses, before you even start using your computer, it tends to increase over time. So now I would say with Windows 11 eating 5 or 6 gigabytes of RAM by the time you start up your computer, you're going to want to have at least, I would say, another 8 that you can use for your applications. So I would look for computers in the 16 to 32 gigabyte range. For a smartphone, significantly less, but a lot of modern smartphones do have 8 and 16 gigabytes now. So if we think about it, if we think about how RAM gets used by applications, this is that temporary or working memory that also is used when you use different apps. So when I open a word processor and I start typing an essay, before that essay is saved to my permanent storage, if you were to rip the power cord out of my computer, the contents of that essay are now gone. That's the idea of volatile storage. That's what RAM is. It's only operational while the computer is powered on. So what we have to do is we have to save it, and that saves to our permanent storage. Now when we close Microsoft Word, all the RAM, all that temporary memory that it was using to display your text in Microsoft Word, and to keep different information like the styles you set, the formatting, etc. Once you close it, that's all wiped from the RAM. So that's why it's important to save your documents, of course. So more RAM is going to allow for more multitasking. I've already kind of given you some idea about what to think of in terms of capacity, 16 to 32 gigabytes. But you also have to balance that once again with battery consumption. So this is why I actually like laptops with about 16 gigabytes, because I find that's the sweet spot for having a lot of RAM to do multitasking, but having a long battery life. So how is memory measured? I've thrown out things like 8 gigabytes and 16 gigabytes, but we need to actually understand a little bit about storage capacity. So storage on a fundamental level comes down to the bit. A bit is either a 0 or a 1. When you think about a wave, we can only really represent 2 states in a machine, and that's a 0 or a 1. Now to represent a single character, like the letter A or the number 1, we actually need a combination of 8 bits. And that's so that we can create addresses and say this unique combination represents a capital A, this represents a lowercase a, and so on. So that's what we call a byte, 8 bits. That's where we start this pyramid that you see on the screen. From there, we have the kilobyte. So we're moving up by the metric system, or we're moving up 1,000 places. So a kilobyte is 1,000 bytes. That would be 1,000 characters. If you think about it, that would be like several paragraphs, right? A megabyte is 1,000 kilobytes. To give you some perspective on size, a modern high-definition image might be 2 or 3 megabytes. And a gigabyte is 1,000 megabytes. So this might be 100-something images. And then we have a terabyte. That's 1,000 gigabytes. If you're a gamer, you probably have a few terabytes in your computer to store all your games, all your mods, and your DLCs. And then we have the petabyte. This is when we get into the realm of databases, large-scale storage. That's 1,000 terabytes. So when we think about your storage needs for a modern computer or a modern smartphone, it's really subjective. It's really going to depend on a number of factors. So I've given you a little bit here to think about. So it's going to depend, number one, on how much media you store. So how many photos and videos and files are you currently storing? You can go through your phone and you can see, oh, I've stored 10 gigabytes in the past 2 years, right? Other factors that are going to affect how much storage you need are whether you plan to store your personal files in cloud storage, if you pay for Apple's iCloud, or Microsoft OneDrive. So to start, you want to know how much the operating system takes up. For example, Windows 11 takes up 64 gigabytes just to install it. And that's before you add all the custom applications that you want. That's before you start creating your own files. You also need to consider how large the applications are that you know that you like to use, and how big are the files they're generating. So for example, Microsoft's Word, PowerPoint, and Excel each take up 1 to 2 gigabytes. A Word document with several pages of text and a few large graphics might only be a few kilobytes. That's less than a megabyte. But you sprinkle in a few images and graphics, and that could easily scale up to a couple of megabytes. A 15-slide multimedia-rich PowerPoint file may easily take up 10 to 3 megabytes, or 1 to 3% of a gigabyte. So look at how much storage you're currently using with your files. Consider the size of images, especially if you're a photographer or you just like taking lots of pictures. And then plan for the future. Use your existing considerations to estimate how much storage you need, and then throw in some extra, right? Storage is much cheaper than it was 10 years ago. It's astronomically cheaper than it was in the 1960s. So as long as your budget allows for it, I say buy more storage than you think you need, and a little bit more RAM or memory to future-proof your device so it lasts longer. Investment. All right, so I've already talked quite a bit about storage, and I kind of jumped the gun, but we kind of have two major mediums when we talk about storage, and that's the hard disk drive and the solid state drive. So the hard drive has been around for a long time. In the 1980s, this was really the beginning of the personal computer era. Hard drives were a staggering $290 per megabyte. So if you think about your Word essay that maybe takes up about a megabyte, imagine paying $290 so that you could store that. That's insane. Now the price per megabyte dropped very steeply in the 1990s, and HDDs were starting to get common. Today, it's so cheap that an 8 terabyte, remember that's 1,000 gigabytes, an 8 terabyte hard drive costs just about $120. That's $0.0000137 or 1.4 cents per gigabyte. This is the dollar calculation per megabyte, but 1.4 cents per gigabyte. That's way cheaper than it used to be. A magnetic disk is what is actually making this work. So a hard disk drive has this spinning magnetic disk, and it's spinning at a rate of 5,400 or 7,200 rotations per minute. Moving parts tend to wear out the fastest, and disk drives are not an exception to this rule. And that's also moving parts, because it requires that spin, it's a lot slower than this other storage medium we're about to talk about. So that other storage medium is the solid state drive. This actually is purely electronic or electric, so there are no moving parts. It's just using electrons. So that makes it much faster, but it is a more expensive technology. That being said, it's gotten a lot cheaper. So some of the pros and cons when we're weighing a solid state drive versus the hard disk drive. Solid state's faster. A con is it is more expensive. Pro is it's not mechanical. Another factor with laptops to consider is the weight, right? Solid state drive is going to weigh a lot less. It's also going to hold up if you drop it or bang it around a lot more than that hard disk drive will. So that's the idea of it being shock resistant. It's also better for storing operating systems. It's going to load things faster into the RAM.